Thank you, David. Thank you for that. Well, I guess the advantage of going first is I can talk about just about anything without it seeming like I'm just repeating what you've already heard. And I'm going to take advantage of that a bit and talk fairly broadly, but the disadvantage, of course, is that you're going to hear later from people who know much more about individual topics within my talk than I do, so you'll probably discover that almost everything I tell you is wrong, but at least I'll get the discussion going, I hope, a little bit and stimulate a little bit of thinking about this subject, which is about the intelligence in city infrastructure specifically, but I think more broadly than that, how electronics and wireless interconnection is enabling intelligence to go into systems and environments more generally, and some of the impact that might have on things like the way we do business, the way we interact together. There'll be a little bit of technology, but if I start off with an example of kind of things that you're already familiar with, this is moving pretty rapidly now in the consumer sector to the internet and to each other and to you as a user in different, more sophisticated ways. These things are starting to be strung together in proprietary systems for controlling, let's say, kitchens, and then more broadly homes, and then eventually more major buildings. So this is not really looking into the future. This is something you can go out and buy now, and I think all manufacturers are behind it. But so far, it's fitted more or less into established business models and established suppliers, so that, for example, when you buy a washing machine, you still buy a washing machine from a washing machine company. But where we're moving in a direction is a very distributed, very high density of intelligence in environments broadly, so the natural environment, the urban environment, the home environment, the work environment, all these things. And one of the things that's making that possible is, as this kind of pictorial slide is trying to show you, is just very small wirelessly enabled, intelligence-enabled electronics, which means that we can put particularly sensing intelligence into just about everything at very low cost. And that makes the possibility of controlling systems in a much more sensitive and much more dynamic way, and ultimately in a way that doesn't require so much intervention by the individual user, but allows a much more complex control to be going on kind of in the background. We're already seeing the benefits of this because of reductions in the cost, size of underlying electronic technologies, particularly computational technologies, sensors themselves, wireless technologies, even to some extent actuation. I'm just going to insert a little bit about engineering challenges, which is this challenge. There's only going to be 2 slides on this, but my own specialty is in hardware for wireless sensing in smart environments. And one of the critical difficulties of putting tens of thousands of sensors everywhere is you need tens of thousands of batteries, and that's going to be really an unacceptable burden. I think probably you're all familiar with the tedium of changing the batteries in the 2 or 3 smoke detectors that you might have in your house. If you had 500 sensors in your house or 1,000, you wouldn't particularly want to spend every weekend going around checking 500 batteries. And if we do the same kind of density of sensing in a city, I did a kind of crude analysis and worked out that on the density which would be useful, we would need maybe 50,000 full-time people to go around making sure that these things were supplied with power. So one of the things that my own group is very involved in is finding ways to power electronics that are embedded in the environment by drawing their power from ambient sources. This is a topic I could go on about for the rest of the day, but I won't, just this one slide. So there are ways that you can take power from human motion, from machine vibration, from airflow, from heat flow, all kinds of things. And we're making a whole variety of tiny devices that are going to make sensing technologies, wireless technologies, self-powered and therefore able to operate autonomously essentially forever, so you kind of can install them and forget about them. And this is going to enable us to really start implementing some of these very intelligence-enabled solutions. So a further plug for work in Imperial is that we've put together a lot of these things into a very large program which encompasses half a dozen engineering departments and the business school. And what we're trying to look at is how the technologies affect the systems that they're adding intelligence to, and what possibilities that can create, for example, to add consumer value, to improve safety, to improve energy efficiency. And one of the things we've discovered in the course of doing this work is that one of the benefits of doing very dense intelligence in systems and connecting them to each other is that you can start to link models together. And a lot of what you need to do to make sophisticated control of systems is to be able to model them. So, for example, we would like to be able to predict energy demand on a very dense basis, both in space and time. So as the energy supply system gets much more distributed, we can take advantage of the efficiencies that you can gain by these kind of predictive methods. And prediction then doesn't just mean predicting what's going to happen within the energy supply system, but maybe predicting how people are going to move in the transport system. That may be related to the weather. And the other thing that happens when you start stringing all these systems together is that you get new business opportunities and indeed new business models of how you can extract value from all these things. So one of the obvious challenges in cities is peaks. We have very peaky demand. You probably experienced peaky demand in the transport system this morning, and there's peaky demand in energy supply, which is partly related to that transport issue, but also in communication systems, in other kinds of infrastructure systems, in systems like security demand and so on. So some of the peaks are regular predictable peaks, like daily rush hours, but also occasional peaks that are associated with, for example, natural disasters or major public events. And this puts an enormous strain on all our infrastructure systems, and it also limits how much we can do with the infrastructure that we put in at vast expense. So if you have a system where the peak is 10 times the average demand, then essentially you're saying, if I want to be able to cope with my peak, I'm going to be wasting 90% of my capacity most of the time. And of course, that is the situation we're in with a lot of systems today, and that's horrifically wasteful. And if we can use intelligence to overcome some of that, of course, the benefits are pretty obvious. The trick then maybe is, how do you connect those benefits with an investment case? Because oftentimes the capital costs of putting in infrastructure that allow you to monitor and control and understand and model these systems on the scale you need to gain these benefits is not done by the people who are going to see the benefits from them. A bit like in the way that telecom systems can add a lot of, let's say, network bandwidth capacity at vast capital expense themselves, and then over-the-top companies like Skype and so on come in and take advantage of that without having paid a penny for it in the first place, and actually get use of it so quite cheaply. So there's some big business model issues, and there are issues simply both technological and operationally of connecting all these systems together. So, for example, supermarket refrigeration is a big energy demand. Weather is a big controller of human behavior, and this all relates to energy systems. So, for example, can we adjust the control of refrigeration in supermarkets according to the expected usage within the next half an hour to an hour based on predicted patterns of people movement in the transport system and very local weather arrangements? So if the sun suddenly comes out, everybody's going to rush in and buy some ice creams. I mean, that's a kind of trivial example, but you can do that in a much more sophisticated way. And there are great possibilities in stringing all these things together to gain benefit. But big challenges, and the challenges are not always so much technological, but often they're business challenges. So one of the obvious things about dealing with peaks is to try to shift demand, and this is something that's a big topic, and it's been really a big topic for a long time, which is trying to smooth out energy demand by changing patterns of usage. And, well, in this country, there was already multiple, well, at least dual tariffs, I think as early as the 1960s or 70s, where you could heat the water in your storage tank at night and at a much lower electricity price in order to shift some demand that way. But it was a very crude system. Now we have the possibility of doing it much more dynamically on a much shorter time scale. We have that built into the supply system. But one of the interesting issues about that is you don't want to get a text message every 15 minutes saying, price of electricity has just dropped by 3p a kilowatt hour. Would you like to turn on the washing machine now? That would be terribly tedious, and you might only be saving 10p, and really, who cares, right? But if that's completely automated, maybe that would be fine. But now think about what that automation implies. So if you put in some kind of home operating system, and quite a few suppliers are now offering these things, suddenly your operating system, a piece of software, is making spending decisions on your behalf. It's saying, okay, I'm going to buy electricity now because the price has come down a little bit. I'm going to use it to do this task. You're going to have to put in some constraints on that system. The people who develop the software, they are going to decide the type of constraints that it's going to allow you to put in. And so essentially, you're giving over some of your financial autonomy to software developers in order to get a convenience and a money-saving benefit. And you could sort of take that farther in your mind. So if you think about the software as a kind of software agent, a kind of software robot, if you like, that's making decisions for you and controlling some aspects of your life, like the way your house operates, then people who market things like energy might decide that why market to you, a human being, why not do the marketing directly to your software agent? And so now you might find a whole commercial ecosystem which is just between different software robots. And I think this is probably quite challenging to a lot of people, but will almost certainly happen anyway. So we need to think about what's the best way to make that happen. For some of us, that'll be how can we make money by participating in this? For others, it'll be how can we protect the consumer so ultimately these things are working in the consumer's own best interest. And you will have business model changes like, for example, once a software system is essentially determining how to control your energy consumption, then they're inevitably going to decide to just sell you the energy in the first place. And they'll buy the energy from a more traditional company that actually owns infrastructure. And there'll be a couple of guys with trendy beards, and they'll be sitting in a cafe and deciding how much your energy costs. This will be disruptive to massive companies with enormous capital investment. But in a way, it's a bit like Uber. You come along, you don't need to, Uber didn't have to buy 1 million taxi cabs in order to start taking over that kind of transport for the ordinary consumer. They just put something over the top of the infrastructure that already existed. So then you'll have also blurring of industry sectors. So you might have, I mean, this is sort of Microsoft and Eon twisted around, but not only is there opportunity for startups to come in and do some displacement activities, but there'll be great temptations for big companies to shift their emphasis, a bit like IBM a long time ago changed from being a builder of big computing boxes to being a consultancy. I think we'll start to see in industries in the next few years, big companies also seeming to become something else. Maybe Volkswagen will have to become something else soon, but that's a different topic. There are some concerns to watch out. So when we connect all these systems together, if you've got your energy system connected to your transport system, connected to your household control system, and there's no overriding control system on the whole thing because none of us want that, but there is a danger that failure in one, either malicious failure or just accidental failure, will spill over into failure in a lot of other things. And so one of the things that's a big concern for systems researchers is to try to protect the resilience of systems and to make sure that our entire city infrastructure isn't going to fall over because of some failure in one part of it. The point I made earlier about giving some autonomy to software systems to make decisions on your behalf, I think this is starting to become discussed quite a bit very recently. If you think about agents, I've used this Downton Abbey analogy. If you're running an Edwardian household and you have servants, then they make a lot of decisions on your behalf, but they do it always with your benefits in mind, you hope. A lot of the software agents we run now, because they come free from big suppliers, not necessarily always working in your best interests. They have the interests also of the organization that provided them to you at their heart. So I think an absolutely critical thing is to think about when you have agents that are given some autonomy and some authority, who are they really responsible to? And if you're giving over your authority to them, you've got to make sure they work for you. I can see I'm running out of time, or I've already run out of time, gone on a bit further. But there'll be lots of kind of new business ecosystems to do with data. We'll have data banks, data stores, so that we can all exchange the data that will allow us to do this kind of decision making and find control of our lives. I think I should probably stop there. We can see a path from electronic components to electronic products to smart systems and finally to smart cities. And probably we're somewhere around here at the moment, and we're moving fast down this path. I'll stop at that point.